Hi everyone, I hope you're okay, and I really hope that guys the videos we keep uploading are helping you out. Uh, this is the eighth video, guys, which simply means I'm doing the eighth question from the 33 questions that I will upload, and all of these questions are just extracted from past exam question papers, guys. So it's it will be very smart of you to take screenshots before you listen to me attempt the questions on your own, and then if there are things you're not sure about, just continue watching the video, and then I'll definitely unpack it. Before we even start, guys, please don't forget to subscribe. Don't forget to comment. Do ask questions on the comment section as well. That's allowed. Yeah, and please like and share to your peers. Okay. Before I even start, guys, to answer the questions, I just need to go and analyze each and every compound here. Uh, in compound A, I can see that I'm given a structural formula. No, it's a semi-structural formula actually. So whenever I'm given a semi-structural formula, I must draw a complete structural formula. It should have C with double bond, and then I have CH3 over there, and another CH3 over there, and then this carbon only has one hydrogen as well as a CH3. So all I have to do is to just write the hydrogens there. Are you scared? So the IUPAC name of this organic compound, you can see that the parent chain has 4 carbons. I'll start numbering from the left. 1, 2, 3, and 4. The IUPAC name for this hydrocarbon, in carbon number 2, I have a side chain, so that's 2 methyl. My parent chain has 4 carbons, so the prefix will be but. And in carbon, between carbon number 2 and 3, I have a double bond. So I'll always pick a lower number and then write my suffix would be in, since I'm dealing with an alkene. Okay, then compound B, I can see that I have a triple bond there, and this will be my longest chain. Are you together? Please, guys, don't make a mistake of saying this is your longest chain, and then that's your side chain. Now, such side chains are never at the terminal carbon. Side chains are never at the terminal carbon. So my longest chain, so my longest chain will be this one. Are you together? And obviously, whenever I number my carbons, I must start numbering them from the terminal which is closer to the triple bond. So this will be carbon number 1, 2, 3, 4, and 5. Are we together? So I can see that between carbon number 2 and 3, I have a triple bond. So whenever I name this hydrocarbon, I'll simply say pent. The prefix will be pent since I have 5 carbons. It's pent 2-ine. It's pent 2-ine. The suffix will be ine since I'm dealing with an alkyne. Okay, compound C, I'm given a condensed structure. If I have a condensed structure, I must draw a structural formula and then give out an IUPAC name. So compound C has CH3, CH2, and another CH2, and then a CH2 that has an OH. All I have to do is to just write the hydrogens there. I can see that, guys, I'm dealing with an alcohol, and the type of an alcohol I'm dealing with is a primary alcohol. Why is it primary? Because the functional group of alcohols is bonded with the carbon which is at the terminal, rather. So the parent chain will be butane, since I have 4 carbons, né? So this will be butane. The OH is at carbon number 1, so butane 1 all. Butane 1 all. Okay, and then compound D, I'm given an IUPAC name. All I have to do is to just draw a structural formula of this IUPAC name. I have 2.2 dimethyl propane. Propane is the main organic compound. Are you together? And then we have side chains in carbon number 2. So I have 1, 2, 3. This over here is the main compound, propane. But then we do have additions. That in carbon number 2, we have 2 side chains. And hence, we'll have something like this. This will be 2.2 dimethyl propane. This is our parent chain. In carbon number 2, I have 2 chains over there. Okay, now let's go to compound F. Compound E rather. Compound E, we are given a structural formula of an ester. Are you together? It has a functional group. This type of a carbonyl ion is called an ester link. Are you together? Okay. Whenever we name an ester, guys, we must start by mentioning the part which comes from an alcohol. Are you together? And how do we see a part which comes from an alcohol? We see it. It's the part that is bonded that is bonded adjacent with an oxygen rather. Are you together? So it simply means that our alcohol only had 1 carbon. Are you together? And then our carboxylic acid only had 3 carbons. So whenever we name this ester, we'll say this will be methyl because the alcohol was methanol, and then the suffix will be propanoate. Propanoate. Why is it propanoate? Because the acid that we used was propanoic acid. Okay, and then compound F, I'm given a condensed structure. All I have to do is to draw a structural formula. I have CH3, I have a CH, another C with CH3, and another CH3. But please note that, guys, you must write down your hydrogens first before I talk about the incomplete bonding that is between the adjacent carbons. Okay, each and every carbon should be surrounded by 4 bonds. Are you together? But these 2 carbons only have 3 bonds. Are you together? Which simply means that there is an extra bond between adjacent carbons and we'll end up having an alkene. Are you together? So our parent chain will be this one, or you can rather say our parent chain is that one. It's up to you. Are you together? And then we'll have carbon number 1, 2, 3, and 4. I can see that in carbon number 2, I have a side chain, methyl. And then the parent chain has 4 carbons. That means my prefix will be but. And then I have a double bond between carbon number 2 and 3. I'll always choose a lesser number, but 2 in. The suffix will be in since I'm dealing with an alkene. Okay, now let's answer the questions. Write down the letter that represents a compound that has a carbonyl group. Compound E has a carbonyl group which is called an ester link. 2.1.2, a letter that represents an alcohol, that's compound C. Okay, a chain isomer of this organic compound. A chain isomer, guys, should have the same molecular formula, but obviously different structural formula. Are you together? Chain isomers, one should have a side chain and the other should just be a straight chain. Excuse me. So on this one, how many carbons do I have? One, this has 3, so I have 4. In total, I'll have 5 carbons. And then the number of hydrogens, it's 3 plus 6 plus 3, that's 12. So C5H12, I'm dealing with an alkane here, guys. Né? So since I'm dealing with an alkane, compound F is out of the conversation, compound A is out of the conversation, compound B is also out of the conversation. Obviously, these are not hydrocarbons, they are out of the conversation. So this is a chain isomer. But let's confirm that. How many carbons do we have? We have carbon 1, 2, 3, 4, and 5. So we do have the same number of carbons. Then hydrogens, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we also have 12 hydrogens together. So these two compounds have the same molecular formula, but different structural formula. So the only compound which is a chain isomer of this compound over here, it will be compound D. Okay, now they want us to write the IUPAC name of compound B. We already did that. We said it's pent-2-ine. The structural formula of compound F, we've already drawn that. It should be like this: CH3, CH2, and then C with CH3, and another CH3 with a double bond though. All you have to do is to just write down the hydrogens. How did I lie? Oh yes, I did. That's the structural formula. Okay, the IUPAC name of a positional isomer of compound A. For positional isomers, guys, we just need to take the functional group to a different location. Since I've drawn the structural formula, guys, I can simply remove the double bond there and draw it here. So this is a functional isomer. No, not a functional isomer rather, but a positional isomer. Are you together? It will obviously have a different IUPAC name. Are you together? So now I can see, yes, I still have 2-methyl, but now I have but1-ene instead of but2-ene. Are you together? It will be 2-methyl but1-ene. 2-methyl but1-ene. Are you together? But others would have preferred not to. Others would have preferred not to take the double bond to that carbon, but maybe place it over here. Are you together? And whenever you do that, remember that you must have a hydrogen over there. Are you together? So the IUPAC name completely changes, because now whenever you number your carbons, you'll start numbering from this carbon. Let me use a different ink. This will now be carbon number 1, 2, 3, and 4, because you always start numbering closer to the functional group. Are you together? So whenever you name this positional isomer, you'll say 3-methyl, because you can see that in carbon number 3 we have a side chain. It's 3-methyl. It's 3-methyl but1-ene. It can be 2-methyl but1-ene or 3-methyl but1-ene. And I believe that if you write any of the two, you will get your full marks. Okay, compound E is formed when a carboxylic acid acts with an organic compound. Compound E is an ester. an ester rather. We need a primary alcohol and a carboxylic acid to form an ester. Okay, write down the homologous series to which compound E belongs. Compound E is an ester. Okay, name or formula of a catalyst used used for the preparation of compound E. It's a concentrated sulfuric acid, ne? It's a concentrated sulfuric acid, and the IUPAC name of that ester is just methyl propanoate. Methyl propanoate. Methyl propanoate. That's how, guys, we're supposed to tackle this question. Thank you for giving me time, guys. I hope that I'm helping you. Please don't forget to share the video to your peers. A thing or two that I mentioned here might help them a lot. Thank you for your time. Bye.